we are going to start multiplying two binomials together. Now, multiplying two binomials is hardly any different to multiplying a monomial with a polynomial, right? There is a technique known as FOIL, which stands for firsts, outers, inners, losts. This is just a technique and it only works for multiplying two binomials. This is just an acronym. It's just a very quick way of multiplying out two binomials, but it's not the only way to multiply out two binomials. So if we take the first question, x plus 3 times x plus 2. Before we get to the FOIL technique, we're just going to explain how to go about and what it all means, multiplying two binomials together. Essentially, we take the first term in the first set of brackets and we multiply it by whatever is contained within the second set of brackets. So in other words, we will have x times x plus 2. And then we add, we take the last term of the first set of brackets plus 3, and again we multiply it by everything contained within the second set of brackets. So we add 3 times x plus 2. Now it's just straightforward multiplication, x times x and x times 2, so that's x squared plus 2x, and then 3 times x and 3 times 2, so it's plus 3x plus 6. Then we just clean this up, collect like terms, x squared plus 5x plus 6. Now, what FOIL means, so just to iterate, it stands for firsts. So we multiply the first two terms together, that's the f. Then we multiply the two outer terms, that's the o. Then the two inner terms, that's the I, and the two last terms is the L. So there's the acronym FOIL. So we first multiply x and x, so that'll give us x squared. We then multiply x and 2, so that will be that over there. We then multiply 3 times x, gives us 3x. Then we multiply the two outer terms, which is 3 times 2, and that is 6. And that gives us the same answer, x squared plus 5x plus 6. So FOIL is just a fancy technique of multiplying out two binomials, and just remember that this technique FOIL only applies to the multiplication of two binomials. A binomial is an algebraic expression that contains only two terms. Any other multiplication, and we will have to use this method over here, where we take every term of the first set of brackets and we multiply it by whatever is contained within the second set of brackets. If we have a third bracket, a fourth bracket, a fifth bracket, the same thing applies. We just keep on multiplying every single term by every single term contained in the other brackets. And number 2, t plus 4 times t plus 3. Let's first, in this example, we're just going to apply FOIL. So we'll use FOIL first and then we'll multiply the alternative way. So t times t will be firsts, then t times 3 will be the outers, 4 times t is the inners, and 4 times 3 is the lasts. So we will have t squared, so that will be the first two terms. Then we'll have outers, which will be t times 3, so that's 3t, and we'll just highlight that as well. Then we'll have the inners, 4 times t. And then finally, we will have the last two terms. And that'll be 4 times 3, which is 12. Then we can just clean that up by collecting like terms. We've got t squared plus 3t plus 4t is plus 7t plus 12. Now we're going to multiply out these binomials, but we're going to do it the alternative way. So that will be the first term, t, times the entire second bracket, whatever is contained within the second set of brackets. So it'll be t times t plus 3, and then plus 4 times the contents of the second set of brackets. So it's 4 times t plus 3. Now just multiply t into the bracket. T times t is t squared. T times 3 is 3t. And 4 times t is 4t. And 4 times 3 is 12. And that equals t squared plus 7t plus 12. Not surprisingly, it's the same answer we got using FOIL. Now, we're not going to do every single exercise, every single problem within this exercise, because it's pretty much, you approach it in exactly the same way as we've just done with these first two examples. So I'll leave this for you to do as an exercise. This exercise from 18 onwards is pretty much the same thing, but there is a trend and a pattern to this, which I'll point out once we've done a few examples. So the first one is x plus 3 times x minus 3. If we apply FOIL, so x times x is x squared, x times minus 3 is minus 3x, plus 3 times x is plus 3x, 3 times minus 3 is minus 9, and then collect like terms, these two terms will cancel and we get x squared minus 9. Next we have t plus 5 times t minus 5. T times t is t squared. T times minus 5 is minus 5t. 5 times t is 5t, and 5 times minus 5 is minus 25. Minus 5t plus 5t is 0, and we get t squared minus 25. Okay, one more before I point out the pattern here. We have m plus 4 times m minus 4. M times m is m squared. M times minus 4 minus 4m. 4 times m is 4m, and 4 times minus 4 is minus 16. 4m minus 4m equals 0, and we get m squared minus 16. Now in the previous example, previous exercise, we multiplied our two binomials and we got three terms. X squared plus 5x plus 6, or t squared plus 7t plus 12. Over here, we're multiplying two binomials and we're only getting two terms out of it. X squared minus 9, t squared minus 25, and m squared minus 16. Now if you look a little bit closer to the brackets, we have x and x, and then we have plus 3 and minus 3. Here we have t and t, and then we have plus 5 and minus 5. In the last example, we have m and m, and then we have plus 4 and minus 4. If you look at these three examples, we have identical first terms, x and x, t and t, m and m, and then the last terms are identical except but they're opposite in sign. So plus 3 minus 3, plus 5 minus 5, plus 4 minus 4. If we look at the rest of the exercises from 21 to 26, the first two terms, t, t, y, y, p, p, 5, 5, 7, 7, x, x, are the same. If you look at the second term of each set of brackets, they're identical but opposite in sign. Plus 2 minus 2, plus 8 minus 8, plus 1 minus 1, plus x minus x, plus g minus g, minus 6 plus 6. When that happens, we have identical brackets but opposite signs in the brackets, at least opposite signs between the two terms. We're going to get a binomial as our answer. Okay, that's because the inners and the outers and the inners will cancel out every single time because we have identical terms in the brackets but opposite signs between the two terms. We'll get to the factorization later. It's called the difference of two squares, which leads us to these specific binomials. right? For now, you just need to recognize the pattern that when you have the first two terms being absolutely identical and the last terms of each binomial being different only in sign, then when you multiply out those two binomials, you're going to get a two-term expression like x squared minus 9 or t squared minus 25 or m squared minus 16. So we'll just do a couple more. Now that we've identified the pattern, we'll just do a couple more. Here, let's do 21 t plus 2 times t minus 2. So basically the trend is when you recognize the brackets are identical, but the signs between the terms, the signs inside the brackets, at least the signs between the terms inside the brackets are opposite, then we're just going to multiply the firsts and the lasts. Essentially, we're not going to do the inners and the outers, the O and the I, because they will cancel each other out just by recognizing what the specific binomials that we're working with. So t plus 2 times t minus 2 will be t squared. 2 times minus 2 is minus 4. 22, we have y plus 8 times y minus 8. So because we have y and then 8 and minus 8 are the same but opposite in sign, this will simply be y squared minus 64. Note that this will only work if the signs between the terms are opposite and the terms, the first terms and the last terms are equivalent in terms of magnitude, right? So in this example, we had t plus 2, t minus 2, y plus 8, y minus 8, p plus 1, p minus 1, 5 plus x, 5 minus x, 7 plus g, 7 minus g, x minus 6, x plus 6. When we have that pattern, then we're going to get a binomial as our answer. And then we just worry about the first two terms and the last two terms. This isn't a rule that you need to learn. Through practice, you'll come to recognize and identify these very easily. You don't have to worry about remembering any rules or anything like that. You'll just multiply out as you normally would. If you're not happy with FOIL, you can always just multiply as we did using the alternative method. So it'll be t times t minus 2 plus 2 times t minus 2, which is t squared minus 2t plus 2t minus 4. T terms will cancel and we get t squared minus 4. If you're not, you don't have to recognize the pattern here. It's just a quick, it just speeds up and saves you a lot of time in exams if you do recognize the pattern, but it's not a train smash if you don't recognize the pattern. It will come with practice. Expand x minus 3 times x plus 3 and then use the result to write down the answers to the following. Do not use a calculator or use long multiplication. 97 times 103 and 197 times 203. Okay, so what this question means is we're going to use whatever result we get here and we're just going to relate it to these products. Okay, so starting off with x minus 3 times x plus 3. Now this pattern that we observed is that we have identical terms. The first two terms are the same and the last two terms differ only in sign, minus 3 and plus 3. When that happens, we're just going to look at the first two terms and the last two terms and multiply them. So we're going to get x squared minus 9. Now we're going to use this result to, again, it says do not use a calculator or long multiplication. So 97 times 103. We are going to have to express 97 and 103 in terms of numbers such that first two numbers are of each bracket are identical. The last two numbers will be identical and differ only in sign. In other words, we are going to have a plus sign. Doesn't matter where we actually put it. Let's put the minus sign in this bracket and the plus sign in that bracket. So we want terms such that the difference of those two terms will be 97 and the sum of those two terms will be 103. So the difference of two numbers will give us 97 and the sum of those same two numbers will give us 103. So we can use a bit of algebra here instead of playing guessing games or trial and error. So the sum, the difference of the two numbers, x minus y, the two numbers, the difference of the two numbers gives us 97, and the sum of those same two numbers will give us 103. Now we're just going to add these two equations to eliminate the y. So 2x equals 97 plus 103 is 200. And then dividing by 2, x equals 100. So the first number in each set of brackets is 100. And then 100 minus 3 will give us 97, and 100 plus 3 will give us 103. 100 minus 3 is 97, and 100 plus 3 is 103. So we have the product 97 times 103. Now using this result, we're going to square the first terms, so it'll be 100 squared minus 3 times 3 is 3 squared. So 100 squared is 10,000 minus 3 squared is 9, and that will give us 9,991. And now you can actually double check that on a calculator. 97 times 103 is 9,991. Okay, next, 197 times 203. So the difference between the numbers must be 197, and the sum of the two numbers must be 203. So adding these now will give us 2x equals 197 plus 203 is 400. Therefore, x equals 200. So we open up our double brackets. The first term in each bracket will be 200. 200 minus 3 will give us 197, and 200 plus 3 will give us 203. This first bracket is 197, and that second bracket is 203, and we're multiplying the two. So 200 minus 3 times 200 plus 3, we're going to multiply the first two terms, 200 squared, and then 3 times minus 3 is, it's minus 3 squared. 200 squared is 40,000, minus 3 squared is 9, and that gives us 39,991. And you can double check again in the calculator. 39,991. And in this exercise, x multiply out x plus 5 all squared. Now, all of these here have got a square, right? We'll get to the more complex ones, 21 onwards in a bit. Just want to illustrate and show you that when you have a bracket that is squared, what this means, it just means that the bracket is multiplied by itself. Now, one thing to note is you may never, ever, ever, under any circumstances, square over a plus or a minus sign. So x plus 5 all squared is never equal to x squared plus 25. What it does mean is that you're just multiplying the bracket by itself. So it will be x times x, x times 5, 5 times x, and 5 times 5. So that equals x squared plus 5x plus 5x plus 25. Then we collect like terms, x squared plus 10x plus 25. When we get to number 21, I'll leave the rest as an exercise for you to complete. We have x plus 2 all squared minus 4. Now, there is a very quick way to find the solution to this, but we'll need to factorize using the difference of two squares first, and we haven't covered that yet. So we are going to write this as x plus 2 times x plus 2 minus 4, and then we just proceed as we normally do. X times x, x times 2, 2 times x, and then 2 times 2, and then we've got this minus 4 at the end. So the 4 minus 4 gives us 0, and this will simplify to x squared plus 4x.